Yeah, great to hear lots of conversations in the breaks. So keep those going because I think that's where a lot of our overlap can happen. So in the design and innovation space, I'm introducing a project called Mass Timber Scrap Reclamation via Furniture Product Designs. Dylan Wood presented earlier. Dylan is my co-PI on this project, and we're actually building off of work that was started in, I want to say 2019, potentially with Linda Zimmer. This is sponsored and supported by the USDA ARS Wood Innovations Grant. So the idea behind this work is built around a framework. I'm actually an interior designer, product designer, furniture maker. So mass timber is not really my realm, but one of the things that we recognize is the mass timber industry is generating plenty of scraps and offcuts after the mass timber material is already produced. And currently, a lot of that material either gets put into long-term storage without any kind of definite need, or it gets chipped up and then turned into cogen steam generation, which is not necessarily a bad thing, but we see that as a large loss of embodied energy. So we've been designing products as a means of exploring the applications of some of those scraps before they get destroyed. So we are looking through a different lens relative to the rest of this conference, where we're really looking at like product designs and furniture changing scales from building and architecture. And then I'll talk about KTM at the end. So if you've been to a few of these, a couple of these pieces are going to look familiar, but part of what we recognized is the drop that's coming off of architectural panels. Some of it is relatively consistent, but a lot of it is kind of job unique. So we wanted to start designing pieces that could essentially respond to available scrap dimensions. So sometimes it's a linear rip off of the top of a panel. Sometimes it's a vertical rip off of the end of a panel, or maybe it's like fenestration cutouts for doors and windows. So the pieces actually can respond parametrically, and this is kind of like we think of it as like the plastic model kits I used to do as a kid, where you punch out the parts. But essentially, you've got a series of small parts, and then this turns into a bench. And at this point, the bench top is essentially what we call parametric, where that can be variable from 4 feet long all the way up to like 30 feet long, because at the furniture scale, deflection is not really that big of a concern. So we are designing and also fabricating kind of initial prototypes as like proofs of concept, and also objects that we can take and share with mass timber manufacturers. We see our work as an opportunity to work and partner with mass timber producers so that they actually take our designs and then they can integrate them into their processes, or vice versa. We could provide them with parts files. They could generate cut parts, and then we could then kind of build a secondary business stream with local craftspeople to actually like inherit the parts, build the furniture, and then have a secondary outlet. So the mesa here was designed by Linda. When this one arrays into a variety of benches, you can actually kind of like interlock them at these end nodes. And then we have like different arrangements and like parallels, 30 degrees, 90 degrees. This one is made from Ferris MPP. And we are also kind of playing within our design scope of how these different designs can adapt to different thickness opportunities. So CLT, of course, 3-ply is conducive to like a furniture object, whereas if we're getting up into like 11-ply, then it's already kind of at a mass that it's insane. But here you can see that we're laminating like 4-inch material, pairing it with 2-inch material, so that the parts can, again, potentially adapt to what material is available. So we're starting to build what we're calling like our furniture library, where we've got a design, we've got the design broken down into furniture components, and then even starting to extrapolate like what material streams these could start to plug into. I'll share a few of the other designs, and then kind of jumping into our work with KTM, I think is particularly exciting at the moment. So this is a piece that we dubbed the suitcase. The one on the left here is actually in Emmerson. So When y'all walk through, you might be able to find that one floating around. But it reminded us of kind of like carry-on luggage, and you can kind of wheel it around in the small format. Once you get into the larger formats, of course, then it kind of just sits in place. But part of the brilliance of this one, this is another one of Linda's pieces, is the cut is essentially done at the same angle. So as you cut one furniture component, you've already made the initial cut for the next piece. So depending on the scrap that's available, if it's a certain width, you could potentially get a series of parts cut out in singular rips, and then you're not having to cut individual components. The Tory bench is another fun one. Here we're kind of taking our interior focus and looking at like scale, proportion, detailing. So one of the challenges of like mass timber is its mass, and it always ends up looking kind of chunky. And then Judith describes a lot of it as like Flintstones furniture. So we wanted to kind of bring our designer eye to this and see what we could do with the material. So even introducing kind of like a fairly simple taper gives you like an opportunity to visually lighten the piece. In this one, we kind of harkened back to kind of Japanese temple structures. The tete-a-tete chairs are really fun. They're 7 feet tall, so if you have larger scrap, this builds off of a precedent in the design world called a tete-a-tete, which is also commonly known as a gossip chair. So back in the day, one person would sit facing one direction, another person would face the other direction, and you can kind of talk about people at the party. So we put our own little spin on it and then made them huge. We thought about cutting a little window in the middle, but then it really started feeling too much like a confessional. So we stuck with this. We had these installed at the hike and bike path in Eugene on the Willamette. They were only out for the summer and really only out for like a month and a half. So we recognize that it's not really conducive to exterior grade material installations. But during the summer dry months, it was great. And it was actually a lot of fun because as people were using the hike and bike trail, one, they were just like, what the heck are these things? But then when they actually started interacting with them, it was quite fun. We've also been looking at very practical applications for scrap material. You know, the furniture is maybe a bigger ask from a manufacturer because that's potentially more time invested, more machining invested. Whereas if we start looking at like architectural products, of course, people are doing like monolithic mass timber stairs, but looking to smaller components to basically build like an available backstock that could then be arrayed into a variety of different arrangements. So over the summer, we had a grad student helping us, UO Interior Architecture Masters and dual degree Architecture Master student. So he was helping us develop some of these kind of graphics and explorations of how kind of like a material-based component logic could then array into a variety of different kind of familiar and known form factors. Again, kind of projecting this to a manufacturer in that like you don't have to store one big piece of scrap. If you're able to start to break that down, then potentially your lengths could be cut to order. But like stairs ultimately don't have a ton of variation in a like traditional sort of passage stair. So then with KTM, this was kind of a growth that came out of different conversations, but KTM, as Dylan mentioned, is a group of OSU grads, and we actually just hired a grad student assistant from, is it computer engineering or software engineering? Computer science. So we've been working with them on kind of a really packaged solution. So whereas manufacturers know what the scraps are when the job is being cut, and ultimately those can be tagged, labeled, et cetera, we're also looking to see what if the scraps get kind of lost in the supply chain. So we're using a process of essentially like camera visual analysis to build height maps of any size, any kind of like dimension scrap. That then gets digitized, turned into digital geometry. And then what they're helping us with also is like a nesting and kind of optimization strategy where if we have our furniture product library with the individual part components, we can use the nesting software to essentially optimize based off of like part rotation and kerfs and all that, so that then like random sized, random shaped scraps can then be kind of optimized towards that process. So where we're at the moment with them, and actually I should mention, sorry, I think I've got the wrong acronym. This was not an NIH, this was a NIFA. But we have a phase one SBIR, which is a small business innovations grant for $75,000 to do this. And we're optimistic about phase two. So right now we're doing it kind of at the small scale. And then we'll actually implement this into the KUKA cell in Emmerson lab to get some like visual analysis. And then if we do adapt up to phase two, then we're looking to like wide scale implementation, and then hopefully partnering with a manufacturer that might be actually interested in applying this and testing it. So they've helped us already into kind of like getting the digital files from the parts sort of scan, and then the nesting, and that also will eventually translate into like generating G code. So we recognize that the machining and programming is the biggest time hurdle. So if we can kind of do that all on the back end, then the software can help us kind of nest and optimize. And then you really just have to do like a final pass check to make sure that overcuts and things aren't getting in the way. So from that, I will pass it off to Chevy and Kyuho.